Hello everyone, myself Shashankyam and I am studying in Sri Venkateswara College of Engineering, Bangalore, and my team members are Sanjeev Reddy, Tejas P and Tanuj MC. And today's our topic is digital decoder with threading, synchronization and the array management. Introduction. A digital decoder is a circular component in various files like communication system, signal processing and compute, computing. It is responsible for interpreting digital signals and converting into usable information. A decoder operation can be optimized by introduction, threading, synchronization, and the array management, which enhance its information and performances in multi-threading environment, particularly when dealing with the large data or the high-speed data streams. In the field of digital signal processing, a digital decoder is responsible for interpreting and converting encode data into a usable format, typically in communication system, multimedia devices and errors correction mechanisms. Literature survey. Parallel digital decoder. Research in parallel example multi-coding processor as leads to improvements in the performances of the decoder, especially in the system requirements real-time decoding, memory management in decoding. Studying Studies on memory management highlights strategies to optimize the handling of arrays, especially in memory intensive tasks like decoding. Threading and synchronization. Various multi-threading modes has been explored to speed up decoding the operation. Errors correction in multi-threading systems. Decoding often involves errors correction algorithm with benefit greatly for threading and array management. Real-time decoder system. In real-time applications, example live video streaming or communication system, ensuring that the decoder operators efficiency and without delay in criticals.
So next we are going to discuss about applications, multimedia applications, audio and video decoding. Video decoding in streaming platforms, example Netflix and YouTube, or video conferring, real-time decoding of high definition video streams in crucial. Audio decoding, digital decoders for audio formats, AAC, MP3, Dolby also requires efficient array management and thread synchronization to ensure seamless playback and reduce buffering time. Communication system, wireless and wired networks. Digital decoders with this optimization decode modulated signals transmitted over different media, ensuring data integrity and minimizing transmission. Augmented and virtual reality, real-time decoding of 3D and impressive audio visuals. Content benefit from multi-threaded decoding, allowing for quick frame rendering and synchronization between visual and auditory elements. Real-time decoding of 3D and impressive audio visuals content benefits from multi-threaded decoding, allowing for quick frame rendering and synchronization between visual and auditory elements. Next, benefits increased throughput and efficiency. Parallel processing, thread synchronization enables the parallel execution of different parts of decoding process. Reduced latency in application requiring error correction. Thread synchronization helps in faster recovery of corrupted data. This is particularly beneficial in communication system where retransmission delays can be reduced by efficient decoding. Scalability. Handling large data sets, array management ensures that even large data sets such as high resolution images, audio files, or long video streams are decoded efficiently by organizing memory and reducing fragmentation. Improved memory management. Reduced overhead techniques like array partitioning and dynamic memory allocation, minimizing the impact of memory fragmentation and optimize memory access partners, further improving the overall system performance.
Now let's see the code of digital decoder with thread synchronization and array management. Hashtag include stdio.h, hashtag include pthred.h, hashtag include stdlib.h. We'll define the maximum number of threads, define max thread 5, define array size, then array size also defined to 10. pthred mutex t mutex. It is the mutex for thread synchronization. Int decoded value array size. Array to store decoded value. It stores the values of digital decoder. Int digital decoder int binary input. If binary input is less than 0, binary input is greater than 15, printf invalid input percentage %d. It should be between 0 and 15 /n binary input return -1. Digital decoder function decodes a 4-bit binary number into the decimal equivalent. Return binary input. Thread function for decoding and storing values. Void decode and store void arguments. Int index is equal to int arg free arg. Int binary input is equal to rand %10. It stimulates a 4-bit binary input, for example 0 to 15. pthred mutex lock 0 mutex. Lock the mutex before accessing the shared array. Decoded value of index is equal to digital decoder binary input. Decode the binary input and store the result in the shared array. Printf thread %d decoded value %d to %d/n index binary input decoded value of index. Print decoded result. It will print the result. pthred mutex unlock 0 mutex and mutex. Unlock the mutex after updating the array. Return null. Now the main function is int main. It initializes the mutex. If pthred mutex init and mutex comma null is not equal to 0, it will print mutex initialization failed. Return -1. Array of thread IDs. pthred t threads max threads. For int I is equal to 0, I is less than max threads I plus plus. Int into index is equal to int malloc of size of int. If index is equal to null, printf memory allocation failed. Return -1. Index is equal to I. It assigns the thread index. The above given statement will create threads to perform decoding. If pthred create ampersand threads of I, null, decode and store, void index is not equal to 0, printf thread creation failed. Return -1. For int I is equal to 0, I is less than max thread I plus plus, pthred join threads of I, null. It will wait for the thread to finish. Printf final decoded values in array. For int I is equal to 0, I is less than array size I plus plus. Printf index %d %d/n I, decoded values of I. This statement will print the final decoded values. pthred mutex destroy and mutex. It will clean up the mutex. It will clean up the all past values in the mutex. Return 0. Corrected the return statement. The output will be thread 1 decoded value 7 to 7, thread 2 decoded value 6 to 6, thread 0 decoded value 9 to 9, thread 4 decoded value 3 to 3, thread 3 decoded value 1 to 1. Final decoded value in array is index 0 to 9.
Results and outcomes.
Increased throughput, data integrity, efficient memory use. Increased throughput. Parallel processing improves data decoding speed, data integrity. Thread synchronization ensures that the decoded values are stored correctly without conflicts. Efficient memory use. Dynamic allocation and array management reduces memory overhead and fragmentation. Conclusion. Parallel processing efficiency, thread synchronization, efficient memory management. Parallel processing efficiency. Multi-threading improves the throughput of digital decoder by allowing concurrent decoding of data, which reduces overall processing time. Thread synchronization. Mutex locks ensure data integrity when multiple threads access shared resources, preventing conflicts and ensuring safe updates to shared array. Efficient memory management. Proper array management minimizes memory fragmentation and ensures optimal usage of system memory, reducing overhead and preventing memory leaks. So the biobibliography, pthreads programming, a postfix standard for better multiprocessing by K. A. Robbins, K. H. Robbins and O'Reilly Media in 2004. Threading in C with pthreads by J. R. White in 2005. Operating System Designs and Implementation. A. S. Taniban, H. Bose, 3rd edition, Present Hall, 2006. Thank you.